Since the early 1990s, there has been a lot of emphasis on implementing intelligent transportation systems, ITS, in transportation management. As a result of the Intermodal Surface Transportation Efficiency Act of 1991, ICE-T, transportation practitioners discovered early that to fully utilize ITS potentials and achieve measurable results, they needed to focus on the intelligence part of ITS. Intelligence needs require data that is both accurate and reliable. Hence, more efforts needed to be focused on testing and evaluating various forms of data collection, technologies, and devices. This resulted in the development of fully instrumented testing and evaluation sites with reliable ground truth capabilities so that all different forms of detection devices could be fully evaluated. Our detector testbed provides a real-world laboratory for the development and evaluation of emerging traffic detection technologies. We can evaluate appropriateness for ITS operations and performance measurement, data quality and consistency, ease of use, ease of installation, and overall cost. The ideal testing site contains a number of contiguous urban freeway locations capable of generating travel time and origin destination information. The Division of Research and Innovations team selected the Southern California ATMS testbed network because it met all of the requirements mentioned earlier. The ATMS testbed is a highly instrumented computer laboratory with high-speed direct communication links to 3 partnering agencies' transportation management centers. These TMCs provide real-time traffic and video data from area freeways and major arterials. ATMS testbed provided funding for 2 sites on northbound Interstate 405 at Laguna Canyon Road overcrossing and the Sand Canyon Avenue interchange. The northbound off-ramp to Sand Canyon Road was also instrumented to capture the vehicles exiting the study area. Each main lane freeway site is equipped with 2 distinct ground truth systems that are utilized to more accurately detect vehicles passing through the test site. The first is an automated video image capture and re-identification system called V2SAT, using fixed video cameras installed directly over each traffic lane. Lorigen Corporation developed this system in cooperation with California Polytechnic University, San Luis Obispo, through a PATH-funded research project. The second is an automated loop signature re-identification system, using double loops in each freeway lane connected to a roadside cabinet with special electronic card readers that record all of the vehicle signatures passing over the loops. This system was developed by IST Corporation in cooperation with a PATH-funded research project on loop signature analysis of city arterials. This is the first time that this system is being used on a multi-lane urban freeway. Traffic and video data generated from these 2 systems are transferred via a wide bandwidth wireless network to a nearby city street signal cabinet connected to the City of Irvine fiber network. From there, the data is transferred to the ATMS testbed laboratories and posted on the internet for general viewing and usage. The 2 ground truth systems are still in the prototype phase and will be calibrated and correlated with other data to enhance the accuracy of both systems for more widespread use on the state highway system. The V2SAT testbed site is equipped with 13 fixed video camera assemblies, 7 at Laguna Canyon and 6 at Sand Canyon. These camera assemblies are mounted on pole bracket assemblies to collect data for video image processing. The 13 pole brackets are permanently attached to the bridge railing at the 2 sites. The camera poles are installed in the brackets each time a test is conducted and are free to rotate and move up and down for fine-tuning and aligning of the cameras. By working from the bridge structure, this arrangement avoids the potential of working above the live traffic lanes. Safety cables on both the pole and the camera assemblies secure the attachments to the bracket assembly, minimizing the risk of vandalism and objects falling into live traffic lanes below. The camera assembly was designed with a great deal of versatility for ease of transporting, mounting, and aligning to minimize work over the freeway lanes. These camera assemblies are connected to an equal number of computers installed in a dedicated roadside cabinet loaded with proprietary software to record the images of vehicles passing the Laguna Canyon site and re-identify them at the Sand Canyon site. The 14th fixed camera set up on the off-ramp location is permanently installed on the mast arm of a roadside pole directly over the lane. These pictures depict the type of data that is collected from these cameras and is processed at a central server located in the ATMS testbed laboratory to re-identify the vehicles passing through the test site. For the vehicle signature system, double loops are installed in each freeway lane at both sites, connected to the roadside cabinets containing proprietary detector cards. These cards produce signatures using the measured change of inductance when a vehicle passes over a wire loop. As seen here, the lights on the detector car indicate the passage of a vehicle. The IST Advanced Inductive Detector cards have a high sampling rate that can produce a high-resolution signature. These signatures can be used to conduct further research and studies related to vehicle re-identification, classification, origin, destination, true travel time, speed, volume, occupancy, section density, and short-term and long-term traffic flow forecasting. Vehicle classification can be done in many ways. The vehicle classification used here petitions vehicle by length. By using common pattern recognition techniques, vehicle signatures can be matched to track the path of a vehicle anonymously for re-identification purposes. Pan-tilt zoom cameras have been installed in the detector testbed to provide both freeway surveillance and security for the fixed cameras when the site becomes permanent. These cameras can be remotely operated to provide optimum view angle. The detector testbed site is capable of testing and evaluating all non-intrusive detector devices such as radar detectors, laser detectors, and any available side-fire detection devices.